Okay, so let's take a look at identifying data structures and the data itself. First, let's take a look at how we're going to import data. And before we actually do that, let's kind of talk about what this data contains. So the data here is related with direct marketing campaigns of a banking institution. The marketing campaigns were based on phone calls, and often more than one contact to the same client was required in order to assess if the product, the bank term deposit, would be yes or not, as in yes or no to subscribe. So what variables do we have? Well, first we have age, and we can see that that looks like it's a numeric variable. We have job, which is type of job, which is categorical. We can look at this and see that there's unemployed, services, management, blue collar, entrepreneur. There's likely a few others if we went through this, but there's other ways in R to manage and identify the unique cases. We have marital status as divorced, married, single, or unknown. We have education, which is also categorical. There's 3 basic levels, as well as high school, illiterate, professional, university degree, and unknown. We have default, so is the credit in default? Yes, no, or unknown. The housing, do they have a housing loan? Yes, no, or unknown. Loan, do they have a personal loan? Yes, no, or unknown. And then we have the contact themselves. So this is related with the last contact of the current campaign. So the contact communication type could be cellular, telephone, or unknown. The last contact month of the year, the last contact day of the year, the last contact duration in seconds. And it looks like this is numeric as well. Now, it could be likely that this attribute highly affects the output target. So if the duration was 0, then y would obviously equal no. Yet the duration is not known before a call is performed, and after the end of the call, it's obviously known that it's yes. Thus, this input should only be included for benchmark purposes, should be discarded if the intention is to have a realistic predictive model. If that makes sense. We also have campaigns. So the number of contacts performed during this campaign and for this client. And this appears to be numeric as well. Now we can look at the structure of all this in R to verify that indeed these are numeric or categorical or strings or factors. We have P days, which is the number of days that passed by after the client was last contacted from a previous campaign. And something like 999 means the client was not previously contacted. We have the previous, which is the number of contacts performed before this campaign and for this client, which is also numeric. And then we have the P outcome, which is the outcome of the previous marketing campaign. Likely categorical as well, because we see that there's failure, unknown, other, and my guess is there would also be success. So let's actually go into R itself and see what we can do. Now, if you are using R, there's a couple things to note. You need to look at the file source. So is this a CSV or Excel file? XLSX. Now, if it's an Excel file, what we'll probably want to do is use the following syntax. So BaseR doesn't directly import Excel files, so we need to install an external package. So we use install.packages, read Excel in quotations. Now this is the library itself. Now up here, this is the scripting area. The console is where performance actually happens, where the calculations actually happen, or any functions or applications. So this way, we can save our script for the future to add additional things, to change things, etc. Now we can use Control-Enter, or just hit the Run button here. So we install this package, read Excel. Now down here, you can see it's installing this package. It installed it, it unpacked it, and checked the MD5 sums to make sure it was accurate. It also shows where that package was saved. Now, we can go to User Library, looking over here, for that XLSX package. Well, it's not here. Why is that? Oh, it actually is here because I loaded it earlier. Well, it might not be there because we haven't loaded it directly into the library. So to do that, we use the library call and say library read Excel. Come to the end of the line, hit Control Enter. It reads that. And you can see once we have this other orange character, then everything has run and it's able to accept a new input. So now what we want to do is set the working directory. The working directory is essentially where files are stored and are accessed. So we use set wd for set working directory. Now my file path is C users mat desktop. Now the thing to know within Windows itself, if you copy and paste file paths, these slashes will be backslashes instead of forward slashes, but R requires forward slashes for these working directories. We run that, now the working directory is set. To verify, we can do get wd with open and close parentheses. Run that, and it shows that's the file path. Now that's where I currently have the Excel file stored. So let's say that now we want to read in the data. So we're going to call the data frame bank customer. We use read underscore Excel is the function. And then the file name that I have is called demo1 identifying data structures .xlsx. So let's run this and see if it works. Perfect. We get the orange asterisk without any warnings or errors, so it was likely ingested, and we can verify over here that the data exists. So there's about 4,500 observations in 14 different variables. The number of observations is the number of rows, the variables is the number of columns. Now, the other way you could do this, if this was a CSV file, and if you didn't want to manually specify the working directory, is you could use setwd again, but you could say choose directory, choose dir with open and close parentheses. Now if we run this, it will show wherever your file folder path may be. So mine's on my desktop, and I hit OK. I can verify that it set the working directory using the getwd function again. And good. That's the working directory. So if we wanted to import a CSV file, we could do bank customer. We'll call this bank customer 1 because otherwise it would overwrite the initial file. And we do read CSV instead of read Excel. And we say demo1 identifying data structures .csv. Go to the end of the line, run that. And oh, it looks like we got a error and a warning message. It says cannot open connection. It says in file cannot open file, no such file or directory. Oh, well, I actually named my CSV file demo underscore 1 here. Let me check. Well, that wasn't it either. So maybe I go look at my desktop and realize, oh shoot, it's demo1 with spaces identifying data structures. Now let's try running it. So we've loaded in the read CSV demo1 identifying data structures.csv, and it also has 4521 observations with 15 variables. Now that makes sense since these are basically the same file. It's just accessing them in different ways. So now what we want to do, I'll just use bank customer from here on out since these are the same file, is we want to get a view of this. So we'll use view bank customer, Control Enter, and the view basically imports that Excel file. So you can see again we have age, job, marital status, education, etc. You can scroll through this as well to get a sense of what that data looks like, to make sure everything was ingested properly, and to try to get a grasp of what that data looks like before doing exploration and visualizations. But it's really important, and the reason we use R is for getting a better understanding of the data itself beyond just scrolling through a CSV file. So we want to look at the structure of the data. So we go to str for structure, and bank customer is the name of our data frame. We run that, and we can see here that this data frame shows that there's 4521 observations, 15 variables. And now we can look through, and we have age, which is numeric, and here's the first few lines of age. Job, which is a character string. Marital, which is a character string. Education, character string. Default, character. Housing, etc. So it looks like we have numeric and character strings. Well, maybe that's problematic for us because we think these are factors and we want to use them for modeling purposes. So what we'll do then is we're going to overwrite the initial bank customer data frame. We'll say read.excel, demo1, identifying data structures .xlsx. But here we're going to say strings as factors equals true. So, for purposes of what we want to do here, we'll use the CSV file. Either one can work, although different files have different ways of handling things, such as the fact that read.excel will import data as strings, as character strings, whereas read.csv will import as factors. So, we viewed bank customer 1. It looks like the CSV file has imported correctly, and we have these different groupings. And then we want to look at the structure of that data, so we run that. And we can see here, it's a data frame. There were 4521 observations with 15 variables. Age is an integer. Job, marital status, education, default, housing, loan, contact, month are factor variables. It looks like P outcome's a factor as well. And notice with factors, it shows you the number of levels. So that's the number of unique classes within that factor. We also have additional integers here. Now, if for some reason we wanted those factors to be character strings, what we would do is use that demo1 identifying data structures.csv, but here we're going to specify strings as factors equal to false. So if we run that, it looks like it ran correctly. And now we look at the structure of bank customer 2, which has set the factors to false. And what you see here is instead of these being factors now they're character strings. So they're just identified as words themselves. This completes demo 1 of lesson 3.